With a good understanding of exponents, it's time to start learning about logarithms, which we're almost always going to just refer to as logs. And to understand what we're doing with logs, so I'm a math teacher, and here's a really simple equation: 6 squared equals 36. And as a math teacher, I could actually make three different questions out of that. I could make this the variable, and I'd have 6 squared equals x. And we know how to solve that. There's not really much to do. We just figure that 6 squared is 36, so x equals 36, and we're done. Another thing I could do is I could make this the variable, and I could write x squared equals 36 and have you solve that. And there's a few ways you could do that. Probably the easiest would be to take the square root of both sides. We know that anytime we take the square root of both sides, we put plus and minus in the answer, and we know the square root of 36 is 6. So we have a way to solve that. The other thing that I could do as a math teacher is I could make this the variable and end up with this equation: 6 to the x equals 36. And I know we know the answer, but as of now, we don't actually have an algebraic way to get there. You don't have an operation that you know how to do that would actually tell you what x is. And this is where logarithms, logs, come in. Log format is useful when the unknown or variable is in the exponent. That's what we have here. 6 to the x equals 36. The unknown is the exponent. And that's what we need logs to be able to do. So the first thing that we want to know about logs is just what the format is. And the big deal here is that these two things in red, these say exactly the same thing, but this is in exponent format and this is in log format. So just take a moment to kind of compare where the parts go here. One thing that we really want to notice is that a log is an exponent. So when we say log base b of a, by the way, that's how we say this. It's log base b of a. That's the correct way to speak of these things. That this is the exponent. X is the exponent here. A log is an exponent. So to convert back and forth between these formats, if we have, for example, this question we were just working on, 6 to the x equals 36, we would write log, the base, the thing that's being raised to a power, is 6, so log base 6. This thing that we might think of as like the output, it has a name in log format. It's called the argument. So in this case, this thing is supposed to come out to 36. And so we'd write log base 6 of 36 equals, log always equals an exponent because a log is an exponent. So again, we've got 6 is the base, that goes here. This is the argument, the output, that goes here. And a log always equals an exponent. X is the exponent, so it goes here. And it's worth considering what this actually says. If we just write log base 6 of 36, if we just write that, a log is an exponent, and this is telling us exactly the exponent that we're talking about. It's the exponent that turns 6 into 36. So if we just saw log base 6 of 36 written, we'd say, oh, that's asking for the exponent that turns 6 into 36, and I know that that's 2. That's what log format means. And again, we use log format when the unknown or variable is in the exponent. So I should add here, let's say that you get this question, log base 4 of x equals 2. Well, if we get this, remember, a log is an exponent. Well, we know what the exponent is. The exponent is 2. It's actually the argument that's the unknown part here. This doesn't belong in log format. So the first thing that we would do is convert it back to exponent format. So the base is 4. The exponent is 2. And it's actually the argument that we don't know here that we can now easily solve for. So sometimes you'll get questions in exponent format that actually should be in log format, and you convert them. Sometimes you'll get one like this that's in log format and really shouldn't be, because the exponent isn't the unknown part. And if that's the case, then you convert it into exponent format and solve. So let's just practice a little bit with what log format is and what it's asking us to find. So using that same sort of phrasing that we did on the last page, if we see log base 2 of 8, this is saying, okay, we want the exponent that turns 2 into 8. Well, the exponent that turns 2 into 8, 2 cubed is 8. So that means 3. Now, one thing about log format that comes up, you can see basically all of these, we say log base something, log base 3, log base 5. If you just see log and there's no number written there, it's assumed that the base is 10. So if you see just log of something, that automatically means log base 10. So this is asking, what is the exponent that turns 10 into 100? Well, 10 squared is 100. That just means 2. And if you feel comfortable with these, go ahead and pause the video, do these last few or try them, and then unpause and see if you got them right. Log base 3 of 3. This is asking, what exponent turns 3 into 3? Well, an exponent of 1 turns something into itself. 3 to the first power is 3. This next one is asking, what exponent turns 4 into 64? Or in other words, 4 to some power is 64. That's just 3. All right, we get a little bit more exciting here. What exponent turns 5 into 1/25? Well, 2 would turn 5 into 25, but we want the reciprocal of that, so we want -2. 5 to the -2 makes 1/25. And the last one, again, when it just says log, that means base 10. So if we wrote this in exponent format, by the way, since exponent format is so much more familiar to us, sometimes it's almost easier to just write it that way. For example, if we go back to this one here, this is saying 4 to some unknown number equals 64. That might actually be easier for us to recognize because we've seen exponent format so much more. Eventually, you'll get more used to log format, but that's always something you can do. So this is saying 10 to some unknown power equals 0.001. Probably easier to think of this as a fraction, or at least the way we would say this is 1/1000th. And so that means, okay, 1,000 is an exponent of 3, so 1/1000th is an exponent of -3. So that's just a little bit of practice with what log format is saying. Let's move on to actually solving some equations where we might end up using logs, and then how we're going to do that. Again, some of these you may be able to just look at and say, oh, I know that 4 squared equals 16. So if this equals 2, then x equals 0. Okay, yes, some will be that straightforward, others certainly will not. But let's just use these as practice for how we would solve these equations algebraically. First thing we would say here is the unknown is in the exponent, therefore this should be in log format. So I'll write it that way. Log base 4, the argument or the output is 16 equals x plus 2, the exponent. We know what this means. This is saying the exponent that turns 4 into 16. Well, that's 2. And then we can solve and get x equals 0. So let's try one that's a little bit more complex here. I definitely meant for that to be a plus sign. So I'm going to change that here. Okay, this will be a much better question now. If we have something like this, the first thing that we want to do is get this sort of exponential part on its own. So I'm going to subtract 4 from both sides. Again, you might be able to see what's going on with the 3 and the 27, but let's just do this algebraically for practice. So I'm going to say, well, my unknown is in the exponent. This should be in log format. So I'll put log base 3, the outcome's 27, argument, I really should say, equals 2x plus 1. This is saying the exponent that turns 3 into 27, so I know that's 3. Didn't quite leave myself room here. I'll subtract 1 from both sides. Then I get x equals 1. That's not right. What did I do? Log base 3 of 27 equals 2x plus 1. That's definitely 3. 2x plus 1 equals 3. Yep, that's right. I'm just being silly. Okay. I'll see if I can cut that out of the video, but if not, sorry. All right, third one. 25 to the 3x minus 1 plus 2 equals 127. Okay. Again, we want to get the exponent part on its own first. We see that there's an unknown in the exponent, so we need to put this in log format. This is specifying the exponent that turns 25 into 125. Now, you can put this in your calculator, but for ones that work out well, where the numbers are designed to work out well, it's nice if we can do this without the need for a calculator. So I'll just come over to the side and do this. This is basically saying 25 to something equals 125. Well, if we take the square root of 125, that's 5. And then we cube that, 5 cubed is 125. So that's saying that this value is 3/2. And the way we know we could do that potentially in our heads is just that 25 and 125, we can kind of see those are numbers that are going to work well together. And then add 1 to both sides. So that's going to be 3/2 plus 2/2 is 5/2. And then, since we're working with fractions here, instead of dividing by 3 on both sides, I'm going to multiply by 1/3 on both sides. It'll just kind of work out more easily. And I'll get x equals 5/6. Now, these 4 that we've done so far are ones that the numbers work out where you could do them easily without a calculator. This one's not, and I just want to show you an example of what that looks like. So I'll start by adding 5 to both sides. Still have that 2 there. That's going to equal 6.6. Divide both sides by 2. Again, we want to get that exponential part all by itself. Okay, so exponential part by itself, unknown in the exponent, that means log format. Base 4, arguments 3.3 equals 2x plus 3. Here. We can just tell by looking at this, this clearly isn't like a nice normal fraction or number. This is going to be some decimal. And so this is where you would use your calculator and find that this value. Now, if you're doing it on your calculator, you should always leave the exact value. Remember, really the only place where it's okay to round a decimal is at the very end of the question when you get your answer. But just for ease of use, I'm going to round at this point. So that value equals 2x plus 3. Subtract 3 from both sides. That is going to be negative 2.14. Divide by 2, and x equals negative 1.07. So those are a few examples of solving exponential equations where the unknown is in the exponent, and so we use log format. The last thing that we want to look at here, oh, sorry, 2 more things that we're going to look at. but it is sort of one topic put together. Logs and exponents undo each other. What do we mean by that? Well, logs are asking what power we need, and then exponents are actually using that power. Well, let's see what happens. So if we have 7 to the log base 7 of 49, well, this part is saying, I'll write this out here. So this is saying exponent turns 7 into 49. And I know it's 2, but let's just think of it this way for a minute. We've got the exponent that turns 7 into 49. Well, what happens if we do 7 to the power of whatever power turns 7 into 49? Well, it's going to turn it into 49. That's going to be our answer. Just to look at that again, we're saying there's an exponent that turns 7 into 49. And then we apply that exponent to 7. What's it going to turn it into? Well, it's going to turn it into 49. And so if you see a question like this, where you have a base and then a log of that same base, they actually cancel each other out. And so we could apply that same logic to this second question here. Remember, log, if we don't see any other numbers with it, means log base 10. So we have base 10 and then log base 10. Well, they cancel each other out and we get 10,000. To think of it the way that we thought of the first question, this part says there's an exponent that would turn 10 into 10,000. If we put that exponent on 10, it's going to turn 10 into 10,000. We don't need to go through all the math. So logs and exponents sort of cancel each other, or I should say logs and bases cancel each other out and make for really easy questions. You'll often get 1 or 2 of these questions that just take really a couple of seconds each, potentially. It works the other way around too. So here we had like 7 to the log base 7. We're going to do this the other way. We're going to have, in this case, log base 3 of 3 to the something. All right, what is this asking? Well, if we kind of use the same format we had before, like log base 3, let's say we had log base 3 of 9, that's saying what exponent turns 3 into 9? If we have log base 3 of 3 to the 5th, this is saying what exponent turns 3 into 3 to the 5th? Well, 5. What exponent turns 3 into 3 to the 5th? Well, 5. And so in the same way that a log and the same base cancel out here, a log base 3 and a base of 3 cancel out here. So here's one in a more general form. What exponent turns x into x to the 5th? An exponent of 5 does that. So the rule that you can take here is that, and I'll write it out here, a base and a log with that same base cancel each other. So this again can make for some really quick and hopefully easy questions.